Today's science class allows us to review everything that we've learned in our chapter study of atoms, elements, in the periodic table. You can see that in the first page that we have, page 33, the first part A, is a vocabulary review, which we have in column 1 all of the definitions that are described, and in column 2 the matching vocabulary terms. We're going to take each of these letters and match them correctly with their definitions. In the second portion, our concept review, we're going to correctly complete each sentence by underlining the best of the three choices. I'm going to circle those so they're nice and easy for you to see. As we read each of those statements, the best answer will be circled or underlined really clearly. And then down here at the bottom, we've got the last bit of our study today, which we're going to label the diagram that shows our understanding of the atomic model, and then the classification of the different types of matter from what we've learned in this chapter. Let's get started with our assignment for today. Number 1, the weighted average mass of an element. When it talks about the average mass, we're learning and looking for the different terms that would be associated with mass, and we have listed right here atomic mass. Number 1 is B. Number 2, a sample of matter that has the same composition and properties throughout. Now, this is what we learned in lesson 3. The same properties all throughout would be something described as a substance. Down here at the bottom, described as a substance. Number 2 is R. Number 3, state of matter that is neither created nor destroyed, only changed in form. Matter is neither created nor destroyed, only changed in form. These are a discovery by Mr. Lavoisier in his experiments with the different types of matter. He learned that matter changes form. It's neither destroyed nor created. It sounds a lot like the law of conservation of matter, which happens to be letter H. Number 4, negatively charged subatomic particles. A negatively charged would be an electron. Number 4 is E. Number 5, the positively charged central part of an atom. Positively charged central part of an atom. Well, it's the central part of the atom. Notice in number 4 it says subatomic particle. Here it says part of the atom. If I was talking about a part of an atom, not a subatomic particle, when it says positive, I'm likely to look at a positively charged subatomic particle, which would be the proton. But here it's talking about the entire central part of the atom in the context of that definition. So that's going to lead us not to think proton in this case, but for number 5 to think about P, the nucleus. The nucleus is that central part of the atom. Number 6, positively charged particle in the nucleus of the atom. So charged particle in the nucleus. Inside of that nucleus, that positive part is the proton. Proton happens to be letter Q right here. Number 7, uncharged particle in the nucleus of the atom. Good thing that all those are listed right together. The uncharged particle is the neutron. The neutron is neutral. That's letter N for 7. 8, elements that generally have a shiny or metallic luster. Elements that have a shiny or metallic luster. This would have been from our study in lesson 2 on metals, nonmetals, and metalloids in the periodic table. We would know that most of the elements in the periodic table are metals. That's the big, huge blue section in the back of your book. That would be letter K. 8 is K. Number 9, matter made up of only one kind of atom. One kind of atom is the dead giveaway in our definition here. That should tell us that that is an element that it's speaking of. Number 9 is F. Number 10 tells you the number of protons in the nucleus of each atom of an element. So the number of protons and this number should be the exact same. As we studied the periodic table and then did our research on the periodic table, we learned that the atomic number is the same as the number of protons. So number 10 is C. 11, anything that has mass and takes up space, that is something that matters. So that's matter right here. It has mass, takes up space. That is letter J. 12, atoms of the same element but have different numbers of neutrons. So any element that has this number of protons is going to be that element. But if it has a certain number of neutrons, like chlorine can have 35 or 37 neutrons, that creates a different type of chlorine in that case, which is called an isotope. That also shows up in different types of elements. I think hydrogen, what was highlighted in your textbook on the different types of isotope that hydrogen can have, as it has 0, 1, or 2 different numbers of neutrons. 12 is G isotope. 13, the sum of an atom's protons and neutrons. If you add those items together, 13, you're going to find out that it is the mass number. Mass number would be the adding of those items together. The atomic mass is the weighted average of the different mass numbers that you might find. This one is the mass number where you're adding both of those together. That's the protons plus the neutrons added together. That's letter I for 13. 14, the small particle that makes up most type of matter on Earth. 14, small particle that makes up most type of matter on Earth. That's going to be all the way up here at the top. That's letter A, the atom. Atom means, in the Greek language, something that cannot be divided. But I think it's ironic that the building blocks of what's created in this world is called atom. Well, what was the first thing that God created in terms of his creation and us as humans? What did he call that? Atom as well. Maybe there's a connection between why scientists have come to describe all the building blocks of the world here, and then how in God's Word it talks about Adam as the first part of God's creation in terms of the human race and everything coming from that. I think there's a little bit of a connection there. In number 15, a pure substance whose smallest unit is made up of atoms of more than one element. So we've got a pure substance. Remember, our substance definition was listed here. Sample matter that has the same composition and properties throughout. So it's this same composition properties throughout whose smallest unit is made up of atoms of more than one element. So you've got more elements added together, but they're in the same composition throughout the entire thing. This is going to be what we would call a compound. Compound's example, H2O. You've got atoms of oxygen and atoms of hydrogen, 2 atoms of hydrogen, and they're always going to be the same in what would make up H2O or water. 16. Formed when 2 or more substances come together but don't combine to form a new substance. So here we've got things coming together, but they're not forming what would be considered a completely new substance. 16 is going to be considered, let's see, M, a mixture. 17, elements that are usually dull in appearance and poor conductors of heat and electricity. Dull in appearance and poor conductors of heat and electricity. Now I should have, as we went through, crossed out the ones that we've used. That way we're not going to get confused. Here's a good strategy when it comes to multiple choice. R, H, E, P, Q, N, K, F, C, J, G, I, A, D, M. Now that points out what we have left in terms of our answers. 17 again, elements that are usually dull in appearance and poor conductors of heat and electricity. I'd be referring to my periodic table to answer this question. Dull in appearance as they're described and how you would view them, and poor conductors of heat and electricity. 17 of the answers that we have as O as nonmetals or L as metalloids. These ones are going to be considered nonmetals. O, cross that out, that means 18. Elements that have characteristics of both metals and metalloids that fall in between that is L for metalloids. That should be the front page. If you need to go back and review because Mr. Shane was working too fast, you can watch this video more than once. Jump into the back side. In Part B, our concept review again, we're going to read the statement and then underline or circle the best possible answer. Number 1, an element is made up of only one kind of isotope, atom, or plastic. Atom. 2, the periodic table lists common molecules, compounds, or elements. It's called the periodic table of elements. 3, isotopes can have the same mass number, atomic number, number of subatomic particles. Number 3 is atomic number, because if it's an isotope, that means it has the same number of protons. It might have a different mass number because you might add those neutrons differently. So atomic number is going to be our best bet. An isotope means that it's a different type of that same element, but it's the same element, which is indicated by the number of protons. The atomic number keeps track of that. Number 4, most elements are metals, nonmetals, or metalloids. The largest of those sections on your periodic table is going to be considered metals. 5, on the periodic table, metalloids are found on the left side, on the right side, or between metals and nonmetals. For number 5, I'd say it's between metals and nonmetals. Underline, circle, make sure that that's highlighted to be the correct answer. 6. A metal, metalloid, or nonmetal has no luster and is a poor conductor. Number 6 is a nonmetal. Dead giveaway when it says no luster. That's another way in which you would describe something's dullness. If it's no luster, it's dull. Poor conductor means it's not going to send heat or electricity through it very well. A lot of the nonmetals in forms of gases are very poor conductors for those different types of things. 7. Many metals, metalloids, or nonmetals can conduct heat electricity, but they are not the best conductors. If they're not the best conductors, that means we're looking for the second best out of these 3. Metals are the best. That means 7 would be metalloids because they're not the best. They can conduct heat and electricity, but they're not as good as metals. 8. The metals, metalloids, and nonmetals are malleable, have luster, and are good conductors. Have luster means that they are shiny. Malleable means that they can be moved and changed into different shapes, and they're good conductors. That's going to be our metals. Notice how all 3 of those are connected as they are in sequence there. Number 9, the elements in a mixture, solution, or compound are always combined in the same proportion by mass. Number 9, the elements in a compound are always combined in the same proportion by mass. Always in the same amount of each different type of ingredient or part of that compound, same amount of elements. Number 10, the compound ammonia contains 3 atoms of hydrogen for every atom of nitrogen. So the chemical formula of ammonia is NH3, N3H3, or N3H. Compound ammonia contains 3 atoms of hydrogen. So which one of these shows having 3 atoms of hydrogen? Well, this one does and this one does. For every 1 atom of nitrogen. This one shows 3 atoms of nitrogen, so our best bet is right here, NH3. 1 nitrogen and 3 hydrogens. 11. An example of a homogeneous mixture is vegetable soup, air, or granite rock. In number 11, a homogeneous mixture is something is the same throughout. Air is going to be the same throughout. Air has this property in which it fills its space, its container. The air that's in one part of the room is going to mix with other parts of the room, and it's always going to equalize and balance. That means it's going to be the same throughout. 12. A mixture is heterogeneous, means it's different if it's made up of 2 compounds, one of its parts is water, or you can see its individual parts. The best answer here is that you can see its individual parts because that is going to show that it's different. Here, our example would be Chex Mix or pizza that has the different types of ingredients on it. In the last portion of our study today, the directions ask us to study the following diagram, then label the atom using the correct terms from this list. Now, earlier in the chapter you had an extra credit assignment in which it asked you to do the exact same thing. Maybe you could use that to help you complete your review, or if you haven't done that, go back and make sure that you do that once you've seen how this works out to be correct. 13, 14, 15, 16, and 17 are going to come from our terms right here in these blanks. Now let's look carefully on where each of these lines are pointed. For number 13, it's pointing to, and it has this little arc on it that's kind of saying this entire central part of the atom. Notice it's not pointing to something specific, but it's more generalized to say, what is this entire piece here? The central part of the atom is called the nucleus. 14 is now really specific. It kind of cuts through and it points to this little dot in the middle that doesn't have anything in it. Because it doesn't have anything in it, it would be considered neutral. Notice that the positives have positives and the negatives have negatives. It doesn't have anything to be considered neutral. Which one of these is going to be considered neutral? It would be the neutron. 15. This little line, if you follow it here, points to a positive center piece. That subatomic part in the middle that's positive is going to be our proton. I like to cross those out as I go to make sure that I'm not going to use the same answer twice. 16 points to this negative portion on the outside in what was called the area surrounding in this diagram. Here's our electron cloud that shows that some of those electrons can be close, some are further away. That's pointing specifically to that electron. So we're going to call that electron, which leads us with the last answer, electron cloud, which is actually the area that surrounds. It's kind of pointing more generally to those areas around the atom on the inside, as we learned in the model of the atomic theory. We've got the nucleus on the inside and the electrons that surround it. Where those electrons exist around it is somewhat unknown and kind of predicted still by science to just be in generalized areas or electron clouds, because they don't know exactly where those items are. In the last portion, it asks us to classify the following by writing matter or not matter in the blank before each item. Remember, matter is something that has mass and takes up space. Let's remember that as we answer 18 through 23. 18, hydrogen. Well, it's an element on the periodic table. It is made up of matter, has a mass, so it is matter. 19, a wish. I wish on something. Sounds like a thought, doesn't sound like it has mass or takes up space. That would be not matter. 20, the sun. It's made of different types of flaming gases because it's made of those different types of elements that exist in our universe. That's going to be considered matter. Now, I'm going to jump to 23. The sun produces light. Light is what we feel and what we see, but it's not matter. It doesn't have mass. It doesn't take up space. Back to 21. Any atom, if it's an atom on a periodic table or an element, it has matter. If it's heat, something that we feel, does it have mass? Does it take up space? It doesn't. So this would again be considered not matter. That should wrap up our study for our chapter review. Make sure that your name is listed on the top, and once you're finished, this goes back into the Monday folder. Hopefully this helps you prepare for what would be your test. You're welcome to use this on your test as well.